So nuclear reactions and chemical reactions, the difference you got. What is the difference?
I think so. No, sir, I don't know the difference.
We are done till here.
Sir, we
Properties.
should. Yes, yes.
Okay, nuclear reaction and chemical reaction. You did not get the difference yet. Nuclear reaction is happening in nucleus. Nuclear reaction is happening in the nucleus, and chemical reactions is happening in the shells. The shells staying outside of the nucleus, where the electrons are staying. Right? Hello?
Yes, sir.
So, chemical reactions we are getting due to the transfer of electrons. And nuclear reaction we are getting due to change of mass of the nucleus. Right? Is it clear?
Yes, sir.
And chemical reactions we are not getting new elements. Like I did we discuss it in last class? The difference between nuclear reactions and chemical
Yes, sir.
reactions.
Yes.
Yeah.
স্যার আজকে নিউক্লিয়ার ফিশনটা শুরু করা উচিত ছিল।
Okay. So that one I was asking you that is it done or not? Already this one is discussed, right? That's why I
Yes,
asked
sir.
you the difference between nuclear reactions and chemical reactions. So you tell me the brief about the difference between nuclear reaction and chemical reaction. Then we'll start nuclear fission and nuclear fusion.
Chemical reaction is only like the transfer of electrons between elements, and nuclear reaction in a nuclear reaction, like radioactivity is given out when radioactivity happens, and it changes the mass of the nucleus, like one element, like element changes.
Yes, that is very important. That in nuclear reaction, we are getting different elements, right? After the reaction. But in the chemical reaction, the elements remain same. The structure of the element remains same. Only the outermost shell electrons they are shared or they are transferred, right? That's the most important thing. And what you said, that is also there, that in nuclear reactions we are having different kinds of emissions, alpha, beta, and gamma, right? But in our chemical reactions, we are not getting that kinds of alpha, beta, gamma radiations. We are having only endothermic, exothermic reactions, right? Some reactions there is heat produced, and some reactions we have to give heat, right? It is taken. Now, nuclear fission and nuclear fusion. At the beginning, we are going to discuss nuclear fission. In nuclear fission, we have heavier nuclei, heavier atoms, like uranium, then cesium, then thorium, These are heavier nuclei, right? Heavier
Hmm.
nuclei means they have more nucleons in their nucleus. You already understand what are called nucleons.
Hmm.
What is called nucleon?
Nucleons is that the protons and neutrons in the
Very
nucleus.
good, very good, very good. The things which are staying in the nucleus, their house is in nucleus. Those are called nucleons. Both protons and neutrons are called nucleons.
Nucleons. Hmm.
Okay, so the nuclei with more nucleons, they are radioactive, where their proton neutron ratio is not same, right?
Hmm.
Proton number and neutron number are same. There is bigger ratio between proton and neutron. There we are getting the nucleus unstable, and they are emitting
Hmm.
alpha, beta, and gamma, and that's why they are showing radioactivity. And such kind of one nucleus is uranium 235. Okay,
Hmm.
and uranium 235 breaks down into two lighter nuclei. Okay, two lighter nuclei, and these two lighter nuclei we are getting from a heavier nuclei. This process is called nuclear fission. Okay,
Hmm.
and which two lighter nuclei we are getting from there? There is another diagram here. We have here barium and krypton. Uh, During the nuclear reaction, we are having barium and krypton. Look, barium is 141, the mass number, and the krypton
Hmm.
is 92. Uranium is 235.
Hmm.
So from a bigger nuclei, we are getting smaller two nuclei. This
Hmm.
process is called nuclear fission. And
Hmm.
what is called nuclear fusion, I am giving also you little bit idea now. Later on, we'll go for more details. Nuclear fusion is the nuclear reaction where two lighter nuclei will fuse together, join together to create a heavier nucleus. That
Just
one
like the
is,
opposite.
yeah, that one is happening in the sun. Two
Hmm.
hydrogen nuclei fuse together to make one helium nuclei. That one is happening in the star sun, the fusion process. This process also giving us huge amount of energy. Okay, more details we are going to have more discussion later. Now we will have more details on fission, nuclear fission only. Look, in
Hmm.
nuclear fission, we are having uh, one neutron is absorbed. This neutron is given to uranium nucleus, and it is given some energy. This neutron in nuclear power station, and this neutron is given, and when the nucleus is absorbing this uranium 235, then it's becoming uranium 236. It is unstable nucleus. Uh, and it's breaking into two parts. We are having krypton 92, then barium 141, and three more extra neutrons are also produced. These three extra neutrons, they are again hitting the nucleus of three more uraniums. Do you understand what I'm saying?
Hmm. Hmm. Hmm.
So when these three are heating more three uraniums, again this process is continued, and that means if we don't control this reaction, it will continue this way, and it is called chain reaction, uncontrolled chain reaction. And during uncontrolled chain reactions, we are having explosions. We are having lots of heat energy produced, and it is happened during the uh, you know during the attack of atomic bomb. In Hiroshima and Nagasaki, the atomic bomb attack happened. That one has uncontrolled chain reaction. There is some way to control this chain reaction to minimize the reaction. We are going to discuss those things later on. Huh? Now you understood that what is called nuclear fission, right?
Hmm.
Now this nuclear fission, uh, only we are not having krypton and barium. Okay, there might be possibility to have uh, strontium, cesium, rubidium,
Rubidium,
and
xenon.
xenon. Yeah, this way indium. Uh, there is possibility to have some more lighter nuclei to be
Hmm.
created also, right? So
Hmm.
you got lots of idea here. Now we are having more discussions from the beginning, huh? More organized discussion here from here. Just in brief, I tried to give you some ideas from this all these discussions. Now you will read it, huh? You read it, please, from here.
Sir, one thing.
Mhm.
How does the at the beginning? How does the neutron? I mean, like, where does the neutron come from?
The neutron we produce the free neutrons, and this
Hmm.
neutron we give in the nuclear power stations or in atomic bomb. Okay.
Oh, and that starts the chain reaction.
Yes, then it starts. Yeah, continue, please.
That's pretty. In nuclear fission, the nucleus of an atom breaks up into two lighter nuclei. Okay, so this is, the process may take place spontaneously in some cases, or may be induced by the excitation of the nucleus with a variety of particles. Example: neutron, proton, deuterons, and or alpha particles, or with electromagnetic radiation in the form of gamma rays. Mhm. In the fission process, a large quantity of energy is released, radioactive products are formed, and several neutrons are emitted. These neutrons can induce fission in a nearby nucleus of fissionable material and release more neutrons that can repeat the sequence, causing a chain reaction in which a large number of nuclei undergo fission and an enormous amount of energy is released. Hmm. Okay.
So this much you understood, right?
Hmm.
Whatever you read, and
Yes.
after this we are having more discussion here.
Sir,
Yeah.
can the neutron, I mean, like, go through barium or krypton like it did in the uranium?
Yes, it can go there, and uh, it will not work like that. The way it's working on uranium. Okay.
Hmm.
They might sleep the nuclei of the cesium. Okay, they will not absorb the neutrons. Okay, they will try to have the reaction with uranium only. Okay, clear?
Hmm. Hmm. Okay.
And if there is more neutrons, free neutrons, they will, uh, in our previous discussions, we had those idea that how we are getting alpha emissions, then beta emissions, then gamma radiations, right? In our
Hmm.
previous class, we had some discussions over there. Can you remember? There
Hmm.
might be some neutron also producing alpha, right? If if this cesium they are emitting, or they are also unstable, right? This cesium also, cesium, rubidium, strontium, they are also having, bigger or heavier nuclei, right? So they are also radioactive. So if something is radioactive, then they also have alpha, beta, gamma radiations. Do you understand what I'm saying?
Hmm. Hmm.
So
Hmm.
if
Yes.
there is any beta decay, in beta decay we are having protons, right? So if you
Hmm.
have
Hmm.
here more extra protons, like if you have two protons here extra, then the neutrons we are getting extra, those can be combined with those two protons and make alpha decay. Okay,
Hmm. Hmm.
uh, and there might be lots of alpha decays here. Alpha decays are also having, some energies. Those are also showing the radioactive properties, right? Ionizing capacities.
Hmm.
So this way, lots of
Hmm.
things are happening here, right? Now continue here.
If controlled in a nuclear reactor, a chain reaction can provide power for society's benefit. If uncontrolled, as in the case of the so-called atomic bomb, it can lead to an explosion which causes massive destruction.
Okay. Yeah, that one already I told you that
Hmm.
we have to control it, right? Otherwise, there will be explosions in the power stations, and it happened also in some of the power stations. You know about the Chernobyl. Uh, can you remember the name Chernobyl power plant accident?
Mm, no, sir, I
Huh?
don't know about it.
About this one, you don't know. That was, in Ukraine. Huh? You know one country named Ukraine.
Yes.
There it happened. It was then part of Russia,
Hmm.
Soviet Union. That time it happened, and it happened due to, uncontrolled chain reaction. They did not control it, and the temperature reaches out of control too much, and that's why there was accident, right? Uh,
Hmm.
it was explosion type accident. Okay, now continue this.
Sir, I had one more question.
Mhm.
I wanted to know, like, how do we know that the neutron to proton ratio is high? I know that alpha decay occurs when there are many neutrons than protons, but I still have a confusion, like, how do we know that the alpha decay is occurring and not beta decay?
Okay, in uh, in some of the materials we have both alpha and beta,
Hmm.
and it it can be understood from the how can we understand? That is your question, right? That it is
Hmm.
alpha decay or beta decay. So at least
Hmm.
we understand there is some radiation coming, right?
Hmm.
And if we are using the electric field and magnetic field, then we
Hmm.
understand, is it alpha decay or beta decay?
Hmm. No, I'm saying like from the equation, like their equation given and like
Okay,
J.
okay. The equation, the representation of equation.
Yes, yes. Like if that A or B is not given, so in order to know which one is alpha or beta, how do we know that?
Okay, so this one is from the equation we understand the mass the element is losing.
Hmm.
You can go back to understand it.
I have my worksheet for.
Yeah, here we can go back. Like if it is alpha, then we are having the mass number change 4. Then atomic number changed 2. We understand it is turning to thorium. So thorium is 90 to 31. So it must be losing 2 neutrons, 2 protons together, and that's
Hmm.
why it
That's
is
alpha it is.
alpha.
Yeah.
Is it clear now?
Hmm.
And beta, we know in beta decay we are having 1 neutron breaks down to 1 proton and 1 electron, right?
Hmm.
Can you remember in last class we did?
Yes. Yes.
So the electron we are getting that is beta decay, and the proton we are getting that is staying in the nucleus and increasing the atomic number. You look here, atomic number increases. We lost 1 neutron, but we gained 1 proton. That's why mass number remains same, but the atomic number increased 1. So from this equation you understand it is beta decay. If your atomic number change 1 but the mass number remains same.
Hmm.
Is it clear?
Right. Yes. Correct.
So now you understood, right?
Yes.
Very good. This way if you have any confusion you please ask me. Yeah. That
So
was also discussed in last class. Maybe you forgot, right?
yeah, I have to check the recording.
Yeah. Now continue here.
Nuclear reactor produces and controls the release of energy from splitting the atoms of uranium. A uranium-fueled nuclear power is a clean and efficient way of boiling water to make steam, which drives turbine generators. Except for the reactor itself, a nuclear power station works like most coal or gas-fired power stations.
Okay. So this one first you get some idea here like clean and efficient, clean and efficient way of boiling water. So nuclear power is clean. Why it is clean?
But because it is not giving any kind of pollution.
Yeah, it is not giving any kinds of carbon dioxide gas or any other kinds of gas, any dust. Okay, any smoke is not giving. That's why it is clean energy,
Hmm.
right? In
Yes.
other power stations, other thermal power stations, we are getting from fossil fuels like petroleum, coal, gas. Those are burned, right? And smoke is produced, carbon dioxide is produced, dust is produced, right? So that one is not clean energy, isn't it?
Hmm.
And in nuclear reaction, we are getting also efficient way of boiling water. You know, the nuclear power station is also called thermal power station. Why? Because here we are also using the same way. the way we have in our fossil fuels power stations. There we are using thermal energy to boil the water to make steam and turn the turbine to produce electricity, right? And same way in nuclear power stations, we are getting thermal energy from nuclear reactions. We are boiling water to get steam, high energy steam to turn the turbines. In nuclear reactions, the thermal energy we are getting that is much more greater than the fossil fuels thermal power station. That's why it is more efficient. Okay, the temperature we are getting it is very high here. Is it clear why it is
Yes,
more
yes.
efficient? Okay, so uh, in this case, we can say a nuclear power station is better as it is clean and it is efficient. It's producing more energy and it is not producing any, greenhouse effect. In this sense, it is better, right? Nuclear power station, but it is
Hmm.
also in other way round. It is also risky, right? Nuclear power stations. We are having, risk if we cannot do it properly. There is possibility to have radioactivity,
Well, yeah.
radioactive emissions occurring. Those are, not helpful for human and other animals, plants, right? And the construction cost and decomposition cost of nuclear power station is very much. It's very expensive. Okay,
Hmm.
that's why it is in that case or in that sense, it's not, you know, efficient for poor countries like us, right?
Hmm.
It is very expensive one.
Hmm.
Okay, now and much more is that it is very, uh, it's creating threat to our environment also. As our population is very high, we don't have so much, free land, right? Or free space where we can make this power station and we can, you know, keep that space empty for a long time because we need food, right? We need some other industries. If we are only doing this power station, then lots of space will be, have to be given for that purpose. So for those reasons, it's not better for our country. The countries like Saudi Arabia, where it has, lots of land, empty land, right? They can do it easily, and they have also money. Now, continue this, please. Several hundred.
Several hundred assemblies containing thousands of small pellets. So what's pellets?
That means, bullet,
Pieces.
bullet, bullet-like things. Okay, small, round shaped. Okay, sphere. Those are called pellets.
Of ceramic uranium oxide fuel make up the core of the reactor. For the reactor with an output of 1000 megawatts, the core would contain about 75 tons of enriched uranium. In the reactor core, the uranium-235 isotope fissions or splits, producing a lot of heat in a continuous process called.
Chain reactions. Yeah, look, you got here another term that is enriched uranium, and sometimes maybe in newspaper also you got this idea that Iran is enriching their uranium, right? The North Korea, they are also enriching their uranium resource, right? In newspaper we are getting, and America is very much anxious. Then Israel is very much anxious that these countries are enriching their uranium. They might be producing the nuclear bomb, which is threat for them. So this one enriched in uranium means for nuclear power stations we need uranium 235. Okay, but in nature the uranium 235 is not available that much. In nature, mostly we are having uranium 238, uranium 234. Okay, so to convert this, the process of converting this 234, uranium 234, 238 to 235, and having greater ratio of uranium 235, that is called enriching uranium. Is it clear to you?
Yes.
Yeah. And the small pellets you understood, right? Pellets. Pellets means like small, small,
Bullets, small
yeah,
bullets.
like bullet like things. Okay. Now we are having some more terms here, you know.
So a
Mo-
moderator shows
Yeah,
the fast neutrons. So
yeah.
a moderator slows the fast neutrons down and makes fission possible. Control rods help in adjusting neutron flux. So what's neutron flux?
Neutron flux is the density of neutron.
Oh, which in turn affects power output. The basic function of these rods is to absorb neutrons while starting a reactor. Um Control rods are pulled out so that power output increases and reach the desired level. The heat released by fission in nuclear reactors must be captured and transferred for use in electricity generation. To this end, reactors use coolants that remove heat from the core where the fuel is processed and carry it to electrical generators. Coolants also serve to maintain manageable pressures within the core.
Okay, look, we are having here three terms. One is moderator, another one is control rods, and the other one is coolants, right? Look at the diagram here. Here, look, we are having the control rods, we are having moderators made from graphite, and we are having the coolants. Coolants, water. Water is given. This is cold to the nuclear reactor. It is given, and here we are having lots of energy, heat energy. This These are absorbed by the coolant, that is water, and coolant is going here. Okay, so we are having the steam over there, right? Steam over there, and this steam is turbine. The steam is turning the turbines. This way, the electricity is generated. Now, coolant means the one which is absorbing the heat from the nuclear reactor. We are using water from for this, absorbing the heat. And here we are having moderator in your uh, reading time. You found that it slows the first neutrons down. So for the chain reaction, for the nuclear reaction, the fission happening, we have the neutron, and that neutron should be of a certain kinetic energy. If the kinetic energy is too much, then it will not be absorbed by the uranium nucleus. Okay, so the moderator, it is made from graphite. Graphite, you know, it's an elastic, you know, like carbon, and it is soft, right? So it's slowing down the fast neutrons. It's decreasing the speed of the neutron in the accepted level and makes the fission possible. So you
Hmm.
understand what is the use of moderator?
Hmm.
Okay.
Yes.
Now control rods, if sometimes is too much energy already produced, then we do not need, you know, to have so much energy now. At that time we are uh, controlling the reaction, right? With the control rods, we are putting this, you know, rods down. If you are putting this rod down, then these control rods help in adjusting neutron flux. They are not allowing the neutrons to be, you know, absorbed or be accepted by uranium if the control rods are going down, right? They are protecting them, the uranium fuel, to you know, to accept the neutrons. Is it clear? That's why they are saying neutron flux. Yeah, they are controlling the neutron flux. Neutron, there might be, you know, uh, much more heat, so they are controlling the neutron density to reach fuel, right? Uranium fuel, so that the nuclear reaction can be decreased. This way, we are making uncontrolled chain reaction to controlled one. Is it clear?
Yes. Hmm. Correct. Hmm.
So you understand what is called moderator, what is control rods, and what is coolant, right? So all these
Yes.
are clear, right? And how to
Yes.
make
Got it.
uncontrolled chain reaction to control chain reaction, that one was also clear. Now we have life of stars afterwards. So nuclear reaction is done here, nuclear fission. Here nuclear fission is done. You have any more questions on nuclear fission?
Mm, yeah, just wanted to recap that how that uh, uncontrolled reaction is going into a controlled reaction. Just a brief one.
Yeah,
Nuclear fission is easy. I got
yeah.
it.
The uncontrolled one, you see, is uh, becoming uncontrolled due to the number of neutrons, too much neutrons, right? If there
Hmm.
is not so much neutrons, then it is controlled,
Hmm.
because the neutron is the responsible to start the nuclear reaction, right? Nuclear fission process. So if somehow we can stop them to reach the uranium fuel, then we
Hmm.
can control them, right?
Hmm.
Do you understand?
Hmm. Hmm. Got it. Hmm.
So this control rods, if there is, you know, less, you know, nuclear reactions, and we don't have so much energy, then these control rods are taken out. Okay, then neutrons can reach to fuel rod, and there will be more chain reaction, right? But this control
Hmm.
rod is going down, then it's not,
And then
yeah,
the neutrals are not
not
coming to
reaching
the
the
uranium.
fuel. Then there is, you know, control, right? Chain reaction is control.
Hmm.
Is it
Hmm.
clear now?
Got it. Hmm. Hmm. Yes, got it. Hmm.
Okay. So now we are
Um,
going to life of stars after some minutes, right? Now it is 5:47. We will start our class at 6. Okay. We are having
okay, sir.
some break for prayers. Then
Hmm.
we'll continue again in life of stars. 6 o'clock. Thank you.
Okay, sir.